Hi guys, we're the Robinson twins. I'm Bob. And I'm Rick. And welcome to another episode of our Earth is a Spherical Home Planet playlist. This is the next episode. Now we know that the flat Earth model indicates that the sun and the moon are circling above the flat plane that MC2 likes to call the dirt pizza. And we know that the sun actually does approach the horizon and even go below because we just know that from observation. We have photographs that show clouds being lit from below and rock formations being lit from below by the sun. And if the sun was always above a flat Earth, that couldn't happen. So we have some examples. Please have a look at what we have to show you.
Here's a picture we took at Crater Lake National Park in Oregon, USA. You can clearly see that the clouds are lit by the sun from below because the sun is just at the horizon. On the flat Earth model, if they even have one, the sun is always going to be higher than the clouds are, so that it can't light the clouds from below. Here's another image we got a little bit later in that same morning, and you can see all the way over to the left edge of the frame, the cloud is lit from the bottom by the sun, something that can't happen on a flat Earth. Here's a sunset in Arizona, where you can clearly see the clouds lit from below. Here's a sunset in my hometown of Fresno, California, USA, clearly showing the sun lighting the clouds from below. Here to point home even further, we have rock formations being lit from below as well. There's an example of an arch in Pfeiffer, Big Sur, California, USA, where at certain times of the year the setting sun appears through the arch and lights up the inside of the arch all the way up to the top of the arch, and lights up the beach behind the arch with the sun shining through it. So take a look at these examples. This is Keyhole Arch at Pfeiffer Beach in California, USA. Clearly seeing the sun shining through the arch and lighting up the beach, which could not happen if the sun was above the flat Earth. Here's a picture of the sun setting with its light shining directly through the opening of the keyhole arch. In this simple diagram, you can see that on a spherical Earth, the sun can be at a lower angle than the bottoms of the clouds, and that's why the light bounces off of them to our eyes. That can't happen on the flat Earth idea or notion, because the sun is always higher than the clouds in their model, or what do they call a model? So we resort to a scientific sounding explanation of refraction. Refraction is a real thing in optics. When light passes through material of different densities, it can change directions. But here's why that doesn't work for them. According to science, we actually see sunrises and sunsets in a delay when the conditions are right with atmospheric refraction. It can be as much as 2 to 5 minutes. So we actually see sunrise before it happens, and we can see sunset after it happens, just because of refraction. In this diagram, the red line indicates the position of the actual sun, whereas the dotted line indicates our view of it, where we see it from due to refraction. The bending light makes it appear higher than it actually is. In the flat Earth notion, the sun is always floating above a flat Earth, so we could never have sunrises or sunsets that go from her eastern horizon to the western horizon. So they try to use refraction to explain that. But here's the problem. If you look in the diagram, the sun is always above the horizon, never sets, never rises from the horizon in the morning, or sets in the evening. So if light is refracted in that direction, which is the opposite of what science tells us, it would make the sun appear lower, but it would never turn dark. So they can't explain why it's dark before sunrise or dark after sunset. But there's another problem too. If refraction worked the way they're claiming, we'd actually see the sun rise in front of the horizon and the sun set in front of the horizon also. It would not go behind the horizon. Here's a picture we took of the sunset at Morro Bay, California, USA. It's clearly at the horizon. Here's a modification I made to that image to make it look the way flat earthers claim refraction works, to make the sun look lower than it actually is in their model. the image of the sun would be in front of the horizon, not behind it. So why does the Earth get dark? If the Earth was flat and the sun was always above it, we'd never have darkness. We'd have daytime all the time. So flat earthers try to say, well, we have nighttime because the sun is like a spotlight and it just turns away from you, so it's not bright anymore. So what is this spotlight made of? Why does it reflect sunlight in one direction and block it from the other? And how does it stay attached to the sun? I mean, the whole idea is obviously made up. But if the sun was like a spotlight and it just turns away from you, you'd still be able to see the back that's blocking the sunlight. So if we can see the sun rise from the east, go across the sky at noon to its high point, then go to the western horizon, and then it just turns away like a spotlight, we should be able to see the back that's causing it to be dark as it moves from the west through the night sky back to the east for the next morning sunrise. No one's ever seen the back of this dark sun, this spotlight sun that they're claiming exists, because it doesn't exist. Here's a graphical representation of the sun rising in the east and setting in the west. And then we see what would happen at night. Well, it would have to move from the west back to the east, and we'd be able to see the back of the spotlight. So the spherical Earth heliocentric model perfectly explains why we have sunrises and sunsets and why the sun appears to move through the day because it's the Earth rotating. Here it's facing the sun if it's in that direction, and you've got sunrise. You're watching the sun the day, and over here you're looking at it the sunset, and then you're in the Earth's shadow. That's nighttime. So perfectly explained with the spherical Earth heliocentric model, whereas the flat Earth model fails miserably.
Thanks for watching. Now be sure to like and subscribe and hit that notification bell for future episodes.